Hi guys, Shouvik and welcome back to the YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have this problems Leetcode 135 Candy. So this problem tagged as an hard difficulty, and I don't feel so. It's a hard, but it's for sure like medium hard kind of difficulty. So because like the way you are going to implement on that, its difficulty is also going to be changed. And there are two approaches, but we are going to discuss the most optimized way you can implement. And if you are implemented on that way, so it's definitely then going to be a hard, and there is no way to you are going to get it rejected to any interview. Yeah. So on this problem statement, they are given in children standing in a line, and each child is assigned a rating value given in the integer array ratings. So they have given a ratings array of the ratings of the children. Now they have given more things. You are given Candies. You are giving Candies to the children subjected to the following requirements. You are giving Candies to the children subjected to the following requirements. What's the requirement? Each child must have at least one candy. Each child must have at least one candy. So that is the first rules that you can't violate. So every child should get at least one candy. The second one is children with higher ratings get more candies than their neighbors. The children with higher ratings get more candies to their neighbors. Yes, agree guys? Definitely. Now return the minimum number of candies you need. Now return the minimum number of candies you need to distribute the candies to the children. Yes, so by following these two principles, we have to distribute the candies among the children, and after the distributions, you have to tell what is the minimum number of candies you need. So on this example test case, you can see 102. So we need 5 candies. How? So you can allocate the first, second, and third childs to with 2, 1, 2 candies respectively. So we have allocated 2 candies to this, 1 candies to this, and last one as 2 candies. So that's the way. Like this children's got more candies than its neighbors. This children is lower, so it got less candies of its neighbors, and this so the neighbors. So if the ratings of its neighbor is more, then it should allocate with higher number of candies. So we are following the ratings, the candies for which the ratings is smaller, we are basically allocating less candies. Agree? Yes, we are doing it very correctly. For this 1 to 2, you can allocate candies 1 to 1. And the third child which gets 1 candy because it satisfies the above 2 conditions. You can allocate 1 candies to this particular child. So that is the beauty, guys. So please take a note on this particular point. 1 to 2. If the ratings of both two consecutive child ratings are same, then we can start assigning candy from 1. Because if we only have to allocate more candies to the child, we only have to assign more candies to the child from its neighbor if its rating is higher. If the rating is equivalent, then we can assign the very minimum candy. And what is the very minimum candy? At least 1 candy. We can assign 1 candy. Because the condition is only this. Children with higher ratings get more candies than their neighbors. Because the condition is very simple. If the ratings is higher, then only we have to think to assign more candies then there is neighbors. But if the rating is same, then we can assign less candies. Then we can assign what is the bare minimum candies we have to assign. We can do that. Yes. So that's the reasons we are doing 1-to-1 arrangement. Now we can quickly see the constant. So on constant is as big as 2 into 10 raised to the power 4. So if you are thinking in kind of a solutions of what can I say, like two pass solutions, then it is going to give you a TLE for sure. Because on that case, your time complexity is going to be 4 into 10 raised to the power 8, and at 1 second we should be allowed to do only 10 raised to the power 8 operations, and you are going to get a TLE for sure. So we have to think of kind of big of in kind of solution. So now if we can go to our OneNote quickly and start discussing the things. So there are 2 approaches. I am first going to discuss the first approach. I am not going to discuss very depth on that, but on high levels I am stating. So on high levels, what you can do, you can do a 2-pass solutions. You can do assigning the candies from forward to backward using the rules. What rules? If ratings are increasing, then you are bound to assign greedily +1 candies from its previous assignment. Elif, if it is a downfall, then you are bound to assign to a -1 candies from its neighbor, because on that case you should be very greedy. If your left is higher, then you are going to decrease your decrease the candies count from its neighbor so that your left neighbor which is higher rating should be more candy. But take a note, but note to take here, your candies count can be 0 or negative, 0 or negative 1 2 like this, right? Negative. So on that case and the last case is else if it is equivalent, if it is equal, like your left and right is equal, then start to assigning one candy, start with one candy assignment. Yes, we can do it is. So only this case is actually the tricky, so that's the reasons I am asking you to do a double pass solutions. What I am basically asking you, when you are assigning candies in the forward go, let's assign the candies in the, oh shit man, it's too slow actually. You can assign the candies in the reverse go. So now you can assign from backward to forward by following the same above principle. Now just to take note, now for the backward, the slope which is decreasing from forward it's going to be increasing from backward. It's going to be increasing from backwards. And then on that case, you can start from the very tough point and do a +1 and like this way you are set the negative or zeros. The negative or zeros you are going to set with the actual values. You are going to set it with the actual values. So that is a 2-pass solutions. I am not going to get too much depth on this, but there is a 2-pass solutions exist. There is a 2-pass solutions exist in the approach 1. So now I am going to discuss the approach 2. So the approach 2 you are going to fond of after listening it. The approach 2. Yes. So I would definitely suggest on an interview, like try to make the discussions with the approach 2 only, because here the time complexity also is going to be shit. It's always doing the same things. This OneNote, man. This OneNote is actually not one to I can create that much pressure to it and it is going to be shut down on everything. So OneNote basically don't want that I will going to make videos. Yes, but I will do definitely guys for you guys. So the time complexity on this case is bound to be for sure of big of 2n, is bound to be of big of 2n, but space complexity I think it is going to be a take of big of n for sure, because we need to store the forward list that you are able to build, and then on that you have to build the backward list, but it is not optimized. So if you are applying for top product based company, they will ask to use some single pass solution kind of big of n, and on space also they should ask you to do a constant space. And now the approach 2 is coming to the picture. So that's the reason I am focusing more on the approach 2 discussions. So approach 2 is actually very intuitive. Approach 2 is coming from intuitions only. So is there any pattern altogether in this particular problems? I can see, I am able to see it. Can you guys able to see? So there are patterns. It can be increasing, it can be constant, maybe it can be again increasing, and it can be then decreasing. And on decreasing also, like then maybe at some point it's going to be constant, and then also it can start decreasing. So there is a pattern for sure. So it can be either increasing, it can be either constant, or it can be either decreasing, anything. So out of this, so what are the steps? It can have either increasing slope. Second one is it can have either decreasing slope. So it's not allowing me to do anything. Wait for the program. Now the cursor is all together here or not? The second one is a decreasing slope, and the third one is a constant slope. Now, which slope is actually problematic? Can you guys tell me? Which slope is actually problematic? Can I say this decreasing slope? Because we are only allowing to do a single pass, that is only a forward iterations, and the problem that we have already saw in approach 1, that is the forward slope, the forward iterations, we may be going to get some negative value from which we are not able to recover. We are not able to follow the principles, because we always have to assign at least one candy to every of them. How it is going to be a problem? So let's take an example. So let's suppose the ratings are going to be 1, then 2, then 3, then 4. Like this way you have assigned the candies. You are very greedy. You are going to start with always one. And then let's suppose the slope is going to be decreased. Slope has started to decrease. Slope has started to decrease. So you are going to get from 4, you are going to get 3 because rating decreased. Then 3 to 2, then 1, then 0, then slope still decreasing, then -1. So we got a decrease. We got a decrease with two unwanted values, not allowed values, because we need at least one assignment. We need at least one assignment, and from there you can say it's again started increasing. It's again started increasing only. It's again started increasing only. Let's suppose it's increasing like this. It started increasing, or it can be either constant also. It can be either constant, anything. But here, are you guys able to see any problem here? I guess it's definitely a problem. It's definitely a problem because for these two guys we have assigned some unwanted value which are not allowed. So ideally, what should be the slope? If this is the test case, then what should be the slope? Tell me, guys. Pause the video, take your time and tell me if that is the slope conditions, that is the rating slope, then how should you like greedily assign it? How should you greedily assign the candies? How should you greedily assign the candies? So this make me cry. So let me guys close it and I can maybe, or is it allowing to do so? No, it will not. It is not able to strengthen this one. The cursor is also hanging. So if I can close this OneNote and restart that options, I'm also not getting right. So I can close it. Terminate. Click on terminate. Close the program. It's not responding. So give me 1 minute, guys. It's fixed so that we can continue. Exception occurred. Very good. But we are able to close it at least. Now if we can open a fresh OneNote, please give me some new page. I need some new page. I don't need to write on this page. Give me some new page. Small it. It's not smalling. Add page. So this page we can start writing on. We can click on our draw. We can select our thing, and now we should be good. Go to our full screen, and we are here. Select pen selected, right? Yes. So we have just saw. We have a case. And also recording is going on. Fine. Recording is also going. So on this slope, I am again writing 1, 2, 3, 4. Then we are going to 3, 2, 1, 0. Then -1. Then it can be either constant or it can be either increasing. So only these two actually create the problems. These two actually created the problems because we have a slope of this. Now tell me, guys, what is the correct arrangement then? What is the correct arrangement then on that case? I'm writing it on side by side only. Is it allow me to write it? So let's start. The assignment should be 1, 2, 3, 4. Then I should be greedy. Rather than starting from bottom to negative, because I need at least one candy for every of them. So I know if I am going to -1 from this particular points, it is going to violate the principles for sure. So rather than I am starting from these bottoms. So I am starting from these bottoms to assigning one candies because that is the ready assignment, right? I am assigned here. Then this is 2. Then 3. This done. Then 4, 5. 4 done. 1, 2, 3, 4, 5. This 5 I can assign. So now that is the ideal configurations. Now that is not a problem. This peak is then not a problem. Can you guys agree with this? Because this peak should be like more higher ratings children, a more higher rating child which is getting more candies from its left, but is it getting more candy from its right? Because here you can see it's getting more candy from its left, but its right, which is a less rating child, but it is getting more candy. So in that case, this peak is altogether not valid. So what is the allocations we have done for our peak? We have to increase. So what should it be? So can I write it? It should be 6. From 5 plus 1 is 6, and from left to it's already it's already valid because we have increased its whatever its previous value to some more powerful value, and we know its previous value is altogether satisfying its left is satisfied. So we, for right satisfactions we have increased the value, so left on in increased value it's also going to be satisfied. There should not be any issue at all. Agree guys? So can I build a formula then? Can I build a formula now? So if you guys see it very carefully, so for negative slope, when it is going to be decreasing, then we have a AP series. We have a AP series starting from its trough point to its peak point, Agree? Starting from its trough point to its peak point. And what is the size of it? Previously, what is the peak value? Our peak was 4. And what's the current what is the current we got it? For which, what is the gap actually we want to find? So we will basically run with our current variables. So current variables, we can start with the current variables. So current we can start with 1, and if it is an increasing, then we can increase our current to be whatever the current plus equals to 1. And if it is a decreasing trough, then we can decrease our current to be minus equals to 1. Then on that particular point, our current becomes minus 1, right? Our current becomes minus 1. Yes, agree guys? And what is the peak for which it becomes minus 1? The peak was 4. So what is the gap then? So can I write gap is so that the number of elements smaller child in this peak and trough point is nothing but peak minus current. Agree? So peak minus current is nothing but 4 minus of minus 1, that is this minus going to be cancelled and it becomes plus only. So how many? 5. 4 plus 1 is 5. So how many elements we have? 1, 2, 3, 4, 5. So we got our AP series. Starting from 1 to n is nothing but the gap. So that many elements we have it. And what is the formula for it? So that many candies we have to assign. So what is the formula? What is the contributions? Of this trough point or the downfall points? Can I write it? It's nothing but gap into gap plus 1 by 2. Because that is the formula. 1 to 5, and gap is, our case is 5. Yes. So gap into gap plus 1 by 2. I can directly get the contributions for this particular trough. But there is a problem. Because we just saw that we need to increase its contributions also. Because we have previously increased, so we can increase the answer plus equals to the contributions, this particular trough contributions, which is correct. But the peak contributions, we have previously add to our answer to a 4 value, which is not valid. So we have to add a plus 6 rather than plus 4. So what is the extra contributions? What is the extra contributions we have to make? So from 4 to 6, that is a plus 2. So how you can get it? Why plus 2? Why not plus 3? Why not plus 4? So that is because your current becomes 2 times negative. Your current becomes what is the expectations? So when we are not going to change it at all. So if it is stopped here, then we don't need to change this at all. But it has stopped to minus 1. So we are expecting to stop it 0. So if I can write it, expected stop of our trough is 1, but actual stop of our trough is current. So which is nothing but minus 1. So what is the delta? What is the delta we have introduced? It's nothing but actual. So rather than actual stop, I have already playing the game with current. So current, and what is the actual stop? What is the expected stop? The expected stop is constant for all the case. It's nothing but current minus 1. So that means current is 1, minus of minus 1 is going to be cancelled and it becomes 2. So we got what is the contributions we have to add to the peak, so that it is going to take all from its 1 to 6. It becomes 1, 2, 3, 4, 5, 6. So we have initialized it with 4, and now we need to assign more values. And what is the extra? It's nothing but my current is how far from 1, because we know we want our current to be stopped. Our trough point is, or the current point should stop at a point of where? Tell me guys. It should stop a point of 1, but it stopped with some current. And what is the delta then? The delta is I think I have wrote it reverse. So it is rather than 1 minus current. So that is the contributions I have to add to my answer, because I have considered previously with 4, but it should be considered with 6. It's considered with 6. Now there is one more case. So that actually the intuitions, guys. If you are feeling the intuitions, no, so then you are not going to get a chance to reject to any interview. Try to explain the problems in that clarity, which I am doing. So now let's consider another same case, 4. Now from 4, if I am going to take a trough of 2, so it's up and it's down to only 2, and from here it can be either same or it can be either increasing, anything. Now on that case, okay, on that case, it's not actually becomes to negative, but it stopped earlier. So what is the greedy implementation for it? What is the greedy? Let's write the greedy, because that's the way we are basically found the reverse slope. The reverse slope, that's the way we have found our reverse slope. So here also you have to found our reverse slope in greedy way. So here we have done with 3 2, but we are greedy, we have assigned 1 and then 2. Yes, agree, guys. Then on that case also, if my formula is going to be what? If my gap formula is nothing but, what is my gap formula? My gap formula is nothing but tell me, current, my peak minus current. My peak becomes 4, my current becomes 1. Yes, so what is the gap then? Sorry. My peak becomes, so that is the updated ones. But what is the actual? So it is 4 and our current is 2. So our current is 2. So how many elements we have at? How many AP series element we have at? 2. So is it 2? Yes, it's 1 2. Yes guys, it's 1 2. So it is working. So what is the contributions of this trough wala or the reverse slope or the downfall slope? It's nothing but same. Write it. Gap into gap plus 1 by 2. Gap into gap plus 1 by 2. Do we need to change this peak in this case? Tell me. So for 2, I can go with 3. Then also you are going to satisfy. But my left is already putting it with some higher values. So on that case, you don't have to do the previously we are increasing the count to be answer plus equals to, our target is 1 minus current. And on this case, our current becomes 2. Our current is altogether not negate. So you only have to do if your current is less than or equals to 0. Then only do it. For this particular case, it's not needed. But if current becomes negative or 0, then it's needed. Right? So can we now write that? Can we try to write the algo now? So what are the happy case? So when the slope is increased, then what should we do? So if it is increasing slope, so what is the current value? We can add it. We can increase it to plus equals to 1. First we have increased it to be plus equals to 1. So that means what is the current last we have found? We have increased it, and as it is an increasing slope. So the first conditions, if my ratings of I minus 1, that is the last ratings that we have found, if my current ratings is higher, so then on that case we have to increase the last ratings that is stored in current, and post that we can increase our answer to be plus equals to current. So that many candies we definitely need to assign to this particular child. Elif block, if your ratings of I minus 1, that is your previous guy, I minus 1, is equivalent to your ratings of I, that is you got a trough of, you got a same slope guys. Then on that case, can you guys tell me? Your current, you can restart. We saw, right? We saw in test cases 1 2 2. So we have assigned 1 candies, 2 candies, and then we have start to 1 candies only, right? Agree, guys? Because on that case we should be super greedy, no? Because we only have to provide more candies from the previous when its rating is higher. If its rating same, then we can start the current to be 1 and we can increase the answer plus equals to current. Else, if that is not the case, if it is a downfall slope, so for downfall slope, if that is the first peak, how we can see, how we can aware of this? So we definitely need a downfall variables, if downfall has started altogether or not. So initially I will mark this downfall as false. So and I guess you guys are already understood, because we are doing a I minus 1th fetch. So we will start with for I in range of 1 to n we are iterating, and inside that we will play this game. And we will start our answer to be already of answer we can start with 1, because the very first guy we can assign 1 candy, and we can assign our current ratings also to be of 1, right? These two things we should be do. Now now how we can know if that is the first downfall started? So on that case, if my downfall So that is the first point where downfall has started. If downfall is equals to false, so that means downfall. That is the first point where we are starting the downfall. So that means from very peak, we are just started to go down. So on that case, mark your downfall to be true because downfall has started. Yes, agree guys. And what else you have to do? And you can and if downfall is going to be started, then you can, what is the assignment you have it? You can do a -1 on that case, current minus equals to 1, and you can store, because that is the first point, right? Downfall has started, so that is outside of this if blocks. This current, so you always have to do a -1, but this downfall start you only have to assign when the very start of the downfall start. You have set it, and you can mark the current value to be in your peak, because that is the peak that you have currently lying from. Their downfall is starting, because we need this peak, right, on the calculations. Now in which points you need to calculate, so that we just saw, that we saw already. So downfall is happening, fine, let's do it. But at the point when it is going to be flatten, or the point it is going to be increasing, these particular points, we have to put that logic. So what are those points? So one point is definitely this. When our previous rating is smaller than the current rating. So there we are increasing. And what is the another one? Another one is this, if the ratings is same. So these are 2 points. So in these 2 points, we definitely need a logic. So what's the logic? If our downfall is true, so that means this is the first block for which it is going to upward. Upward movement is starting. So downfall is completed. Now we are doing the upward movement. So if that is so, if upward movements we are starting, then we have to compute our answer. So calculate the gap. Gap is nothing but my peak minus current. Yes, that is the gap. We have found our gap. Now what else? Answer plus equals to, tell me, gap into gap plus 1/2. Yes, gap into gap plus 1/2. What else? We can make our downfall to be false, because from here upward movement or the equivalent movement has started, right? So these 2 particular blocks, you have to incorporate the same things. You have to incorporate the same logic. And what else? My current is maybe in negative state. So from there we are starting a fall. So what is the assignment then? So we should restart your current also to be of 1 for sure. But yeah, before restarting, we have just missed one more case. If your current is negative, so that means your peak need to be updated. So the peak contributions that we have already considered, if your current is less than or equals to 0, then what is the peak contributions you have to add some more. And what is the more? 1, because we know our current should be lie at 1, but it is not. So we can do 1 minus of current that we can. That exactly the games we have to write it. So if you are able to do so, then you are definitely get an wrong answer for sure, not AC. So for AC, we have missed one more case. So after our entire for loop execution, so after this entire for loop, so this is super slow. So after this entire for loop, so I am just dragging it from the for loop block. So after this, your entire for loop executed. So you again have to check if your downfall is true or not, because for downfall true, we are only considered the answer when it is going to upward or equivalent. But let's suppose your slope is altogether this, then have you ever calculate your answer? Nope. So we have to calculate. So you can use the same logic. So you can find your gap. Gap should be peak minus current. Answer plus equals to what? Gap into gap plus 1/2. And then if your current is altogether negative of or equivalent to 0, then on that case, answer, your peak should needs to get more such value. And what is this? Answer plus equals to 1 minus current. So that delta you have to incorporate to your peak. Yes guys, so that's all about the high levels, the problems or the intuitions building you have to think. I have tried my best to explain. So now quickly discuss the code iterations part. So here you can see I have initialized my n, peak, downfall and current. These all the variables we need, and answer also. So I have initialized my n to be len of ratings, peak to be ratings of 0 initially, downfall to be false, current to be 1, answer to be 1. Now I am iterating for I in range 1 to n. And if ratings of I minus 1 is smaller than I, current rating, so that means peak is, upward movement is going on or maybe started. We are not sure. Maybe going on or maybe started. So how we can check? if downfall is true. So that means we have just completed the downfall, and from here upward movement is starting. It's not ongoing, it's starting. And if it is starting, then gap, calculate gap equals to peak minus current, answer plus equals to gap into gap plus 1 by 2. If your current is less than or equals to 0, then your peak needs to get more contributions to your answer. And what is this? 1 minus current, and you should reset your current to be 1 and downfalls to be false, because from there upward movement is starting. And from this particular bottom line you can start assigning very greedily from 1 2 3 like this way. You can start assigning candies, and if that is not the case, or the general case, your current should going to increase to be plus equals to 1, and that you have to incorporate to your current. Similarly, same slope, two case, if it is ongoing, or maybe from downfall it started. So if that is so, I have wrote exact same code that I have written here, that I have just explained, and that I have just written here, exact same line by line, every same code I have written. Yes, and now this is the point you have to very careful on line number 23. You should be very careful. So here you can see, like here I am basically doing current plus equals to 1 before assigning to the answer, but here I am resetting the current. Why so? Because on this example test case you can see, for 1 to 2, this two that is of same slope, we are not need to assigning more candies to it, more candies to this, or even also we don't have to assign the current candies what we have assigned to this 2 candies, because we only have to assign more candies to its to a particular children when its rating is higher. So its rating is equivalent. Then on that case we should be super greedy. We should start with assigning from 1 candies from here. So that's the reason we have reset our current to be 1. Right? Sorry, this line. So we have reset our current to be 1, and we have increased answer plus equals to current. And if that is not so, so that means downfall. So 2 case. Is downfall is going on or downfall has started? How we can check? If downfall is false, so that means downfall is need to start. Then let's start it. Downfall equals to true. And your peak, let's store it in peak, because you are going to get on deeper valley. So we have stored our peak to be current, and we are doing current minus equals to 1. And after this, Shouvik, welcome back to YouTube channel. So today we will solve another question from Leetcode itself. So after your entire for loop gets executed, right? After your entire this for loops gets executed, if your downfall is still present, so that means you are going to still on the downfall path. So if your downfall is true, then add this particular downfall contribution to your answer. How you can do so? Same logic, same gap equals to peak minus current, answer plus gap into gap plus 1 by 2. Same code. See guys, so this code I would definitely suggest, if you are in interview, put it to some separate variables. This particular things we are using on 3 spaces. Three space we have used it repeatedly, same code without a single line change. I will definitely suggest on interview, put it in a common helper functions and use from there. Not write it on this way. So I for quicker purpose or CP kind of mentality I have wrote it, but let's put it to functions on. Let's put these things in the functions on, and you can see, if my current is less than or equals to 0, let's consider the peak contributions what you have put it. That is not correct. Increase it to 1 minus current. Exactly that things that we have just saw to our 1 node. So now we can quickly see the time complexity of this. The time complexity is bound to be how many iterations we are doing, guys. Single pass solutions only from forward to backward, only for big of n iterations, or more specifically big of n minus 1 iterations. So I can write it for sure of big of n in very happily. And space complexity is going to be constant, right guys? All are variables. See, len of ratings of 0, false, true, 1, 1, all are variables, all are single variables. So space complexity is bound to be of big of 1. So that is bound to be the most optimal time and space complexity you can achieve for this particular solutions. And you can see it's like 98% or kind of like 100% faster than all the submissions over the Leetcode. And yeah guys, and that is bound to be the most optimal time and space complexity that you can achieve for this particular problem. And I know it's a difficult problems, like to understand the approach 1 is kind of simpler versions, but understanding the approach 2, it's definitely in a difficult path. But if you guys are able to understand the entire intuitions till whiteboarding, till 1 note we have done, so then please do subscribe to the channel. Please share the videos to your friend circle who are also preparing for top product based company, and please turn on the notifications so that when we are going to live to our next video, you will going to get the notification as soon as possible, guys. So that's it guys, that's it for today. Let's meet tomorrow with another video question. Bye guys, bye.